So today we're going to learn about how to make plots in MATLAB. So one of the very simplest plots you can make is just to plot a series of data. So one very popular series is the Fibonacci sequence. And that's just adding the two previous numbers to make the current number. Right, so here are the first 8 values of Fibonacci. And so to plot a sequence, all I need to do is call a function called plot and pass in the variable. Right, and so that's Fibonacci. Now notice how the x values have been set automatically. So it starts at 1 and increases sequentially. So the next thing we can do to make it a little more complex is to have actual values for x. So suppose I want x to increase by 0.1 every time. So I might do 0, 0.1, 0.2, 0.3, 0.4, 5, 0.6, 0.7. Right. So now I have an x and y, which is what you're probably more used to when you're creating a two-dimensional plot. And to plot x and y, you just pass in x and then y into the plot function. Right, and so now you can see the y-axis is the same as before, but the x-axis is now no longer 1 to 8, it's 0 to 0.7. Notice that the size of both x and y have to be equal. Right, so if I do this, this is not going to work, right? Alright, so the next thing we're going to do is something a little bit more complex. We're going to plot a function. So the first thing we need to learn about is a function called linspace. Linspace, what that does is it creates the range of values of x for us. So we just pass in where we want it to start, okay, where we want it to end, and how many points in between. So I'm saying x is going to go from 0 to 100 and has 200 points in between. Now to calculate y, all I have to do is sine x. We're plotting the sine function. And so in MATLAB, functions generally apply element-wise, right? So every value of x, you call sine x, and then it assigns the value of that sine x into y. So I'm going to plot x and y again. And so now I see sine x going from 0 to 100. So one thing you might notice about this is the lines are pretty jagged, right? It's not a smooth graph, but you know that sine x is actually a smooth graph. So the reason why that is if we look at x again, let's look at the values. Remember, there are 200 points for about a range of 100. And so that's a very low resolution. The last value here is 100. The second last value is about 99.5, so there's only about 0.5 distance for every unit of x. So to give us better granularity, we might want to reduce the range first of all, and then put more points in between. So let's recreate x. Let's say it's going to go from 0 to 2 pi and have 100 points in between. Right, and so y is going to be exactly the same. We're going to plot x, y again. Right, and so now you can see that it's a lot more smooth. So adding to the complexity of this a little bit, suppose I want to plot two functions on the same plot. And that might be useful if you want to compare two different series. So let's say the second function we want to plot is cosine of x. Just say y2 equals cos x. And so if we type in just plot, we can see some different function signatures for plot. If you look at the third one, it shows us x1, y1, ... xn, yn. So what that's telling us is that for every pair x and y that we want to plot, we just pass them in adjacent to each other. So in our case, we're going to have x and y, and since it's the same x for both y and y2, we're going to just pass in x again, say y2 over there. Alright, and so now you can see both sine x, which is the blue line, and cos x, which is the green line, on the same plot. And MATLAB automatically changes the colors for us so we can differentiate between them. One thing you can do if you want to make it a little more fancy is you can specify a line style. And so those are also passed in adjacent to the x and y's. Right, and so now it's even easier to differentiate between the two lines. So the second chart, cos x, is a bunch of dots. And I made a mistake because the dash is the default. That just makes a regular line. If you put in two dashes, it makes them into dashes that you can differentiate between like that. Okay, so now let's say I want to save this plot to my hard drive, or maybe put it on the internet or a document. So you go to File, Save As. So you see the default file format here is .fig, and that is a MATLAB file, so only MATLAB can read those files. There are some other types of formats here that we can look at, such as PDF. If you want to save it to a PDF and then print it out later, you can save a PNG or a JPEG. So if you want to put it in a Word document, or you're writing a paper, or you want to put it on your blog post, you might want to use JPEG or PNG. And so I'm going to use .fig, since you probably already know what a PNG and a JPEG look like. Alright, so I already made a test.fig. I overwrote it. So now that I have it, so you can see right here, saved into my current working directory. If I want to open an existing figure, I do that through a function called openFig. I pass in the file name, and it opens back up the figure. And so the nice thing about MATLAB figures is that I can still zoom in, right? I wouldn't be able to do that really with a JPEG. It would look very blurry. Of course, I can zoom out, I can use the hand to move around the chart. Right, so it opens back up the same figure I had before, so I can play with it. As if I had made it for the first time.